We are looking at partial fractions, one of the topics in Senior 5 first term. Here we're going to look at decomposition of rational fractions into simpler fractions. What do I mean? For example, if we have a fraction which has a polynomial px in the numerator and it has a polynomial maybe qx in the denominator, this can be expressed into simpler fractions if the degree of the polynomial in the numerator, that is px, if the degree of px is less than the degree of the polynomial in the denominator, which is qx. What do I mean by the degree of the polynomials? I mean the highest power of x in the polynomial. So if the highest power of x in this polynomial is smaller than the highest power of x in this polynomial, then we can express this fraction or this function into a sum, or as a sum of two or more partial fractions, depending on the question that we have. Look at an example. If I have fractions, if I have a sum of two fractions, 1 over x plus 1 plus 2 over x plus 3. These two can be added up to give us one fraction, which is actually 3x plus 5 over x squared plus 4x plus 3. Now, this fraction here, which I call the rational function, can be expressed into partial fractions, and these are the partial fractions that we add together to give us this fraction. So we want to look at procedures of coming from the right hand side, from this fraction, into the sum of two fractions that make up this. So those procedures. So we talked about the degree of the numerator being smaller than the degree or less than the degree of the denominator. Look at this example, this very example. We have the degree here being 1, because here the highest power of x is 1. We have a 1 here. And the degree of the denominator is 2. The highest power is 2. So it means the degree of the denominator is 2. So in this case, this is called proper fraction. So we can go and express or decompose this into its partial fractions. How do we handle this? The decomposition is categorized into 3 types, depending on the nature of the denominator. We are going to look at the first type in this video, and we shall look at other types in the coming videos. So the first type, let me call it type 1. Type 1, that's when we have a denominator which has denominator with distinct linear factors. Distinct linear factors. What do I mean? We are going to use this very example here. If, for example, we want to simplify or to express this in terms of its partial fractions, the first thing we have to make survey about is the denominator. First of all, check, is the numerator having a less degree? Is the degree of the numerator less than the degree of the denominator? If yes, then we go on and ask ourselves, what is the nature of the denominator? Can this denominator be expressed or factorized into linear factors? If it is possible, then we categorize that under type 1 and we are going to see what happens. So if you look at this one has a denominator which is x squared plus 4x plus 3, and surely we can express this in terms of linear factors. This can be as xc plus 1 over x plus 3. Linear factors are ones that have the degree of x as 1. Check this. This has x as power 1. This one also has x as power 1. So if we can express the denominator in this form, then we can categorize this as type 1. So we are going to see the procedures. So what happens? Whenever the denominator has distinct linear factors, then the partial fractions are of the form a over the first factor, which is maybe x plus 1, then plus bar, which is b, over the second linear factor. Whenever the denominator has distinct linear factors like these ones, x plus 1 and then x plus 3, then the numerators, the partial fractions will always take on this form. We're going to see other examples, so that is very clear. And always, after here, we have to find the values of a and b. Remember, we got this from this, so we expect our a to be 1, we expect our b to be 2. We are looking at ways or procedures of converting this fraction into partial fractions, which are these. This is one of the partial fractions. This is another partial fraction. So how would we find the 1? How would we find the 2? Which are the values of a and b? What do we do? The first step is we could simplify the right hand side and try to express it as one function or one fraction. We could get the denominator here. We get the denominator which is x plus 1 into x plus 3, and when we try to divide by this, we get x plus 3 times a. So we end up with a into x plus 3 plus this plus here. Divide this by this, we end up with x plus 1 times bar. We get b into x plus 1. So we've tried to express the right hand side in form of one fraction. Now we are going to compare the numerators. First check the denominator here is exactly equal to this, because when we expand this, we get this. So since the denominators are the same, we can conclude that it means also the numerators are identical. So I can conclude that therefore the numerators, which is x plus 3x plus 5 on the left hand side, is identical to the numerator on the right hand side, which is a into x plus 3 plus bar into x plus 1. Alright, now our task is to find value of a and value of b. We can find these values by assuming values of x. Any value of x will satisfy this equation. But we look out for values of x so that one of the unknowns, either A or B, disappears so that we can be able to find the other. For example, in this case, if I want this A to disappear, I can use the value of x equaling to -3. So if x is -3, what happens? Let's substitute in the equation. When you substitute, on the left hand side we shall have 3 times -3 plus 5, and this will be equal to, the right hand side we shall have a into -3 plus 3, then plus bar, which is b, into x plus, into our x is -3 plus a 1. If we simplify, this will be -9 plus 5, which gives us, this is a 0. -3 plus a 3 is a 0, so this disappears. This goes to 0. So we don't need it. So we remain with this. This is bar into -3 plus 1, which is a -2. When we simplify this, this gives us a -4, which is equal to -2 bar. And when we divide by -2 to find the value of b, we end up with b as a 2. I guess it's what we had in our first in the beginning. See, our b, which was this, comparing to this, it was a 2, and we've also found it as 2. Let's go and find the value of a. So what's the value of a? It means I have to choose another value of x that will make sure that this b will disappear, so that we can be able to find a. So what value of x can I use so that the b disappears? I can use x as -1. Since I have a positive 1 here, if I put a -1 here, this will cancel, go to 0. So when we substitute back to this equation, we have 3 times -1 plus 5 equals 2. This one will be a into -1 plus 3. Plus a 0, because this one goes to 0 when we substitute -1. So when we simplify, this will be -3 plus 5 equals to a 2a. So what we have here, this will be a 2 equals to 2a. So on dividing both sides, we end up with a as 1. So we write our fraction. It was 3x plus 5 over x squared plus 4x plus 3 equals 2. So we've gotten our a as 1. Just substitute where there's a, put 1 over, what was our denominator? Denominator was x plus 1. Then plus, we had a plus here, a b, which was a 2, over the denominator, which was x plus 3. So those are the procedures for finding or for expressing a polynomial, a fraction, the rational fraction like this, into or as a sum of its partial fractions. These are the partial fractions. Let's look at one more example. Example 2. if we have 7 minus x squared over x squared minus 1 into x plus 2. Okay, this is what we want to express into partial fractions. We say the first thing, ask yourself, is the denominator having a degree bigger than the numerator? Yes, because when we expand this, we see this will end with degree 3, yet in the numerator we have the highest power of x as 2. So we can move on. The next step is identify the nature of the denominator. Do we have distinct linear factors? Check. For example, we already have here x plus 2 as a linear factor, but here we are seeing a quadratic factor. But some quadratic factors can be simplified to give us distinct linear factors. So identify. Can x squared minus 1 be expressed in terms of distinct linear factors? Yes, because I'm seeing a difference of two squares, and we know that x squared minus 1 is the same as x plus 1 into x minus 1. So it means we can rewrite this as 7 minus x squared over, now instead of x squared minus 1, we can put x plus 1 into x minus 1 into x plus 2. You see, now we have distinct linear factors in the denominator. So we use the procedures for type 1. So this will have three partial fractions. By the nature of the number of factors that we have, there are 3. So it means we expect 3 partial fractions. So the first partial fraction will be of the form a over x plus 1, then plus b over the next factor, which is x minus 1, then plus c over x plus 2. So in the first type, the number of partial fractions will depend on the number of factors that we have. If there are 4, then we would go and put a d over the 4th factor. So we proceed. The next step is express this numerator, the right hand side, in terms of one fraction. Yes. So the first thing, get the LCM, which will be the product of these, the factors. Then we go on dividing. When divide this by this, we get a into this x minus 1 into x plus 2 plus, let me write here, to be a into x minus 1 into x plus 2 plus, when you divide this by this, we get a bar into x plus 1 into x plus 2. When we divide this by this, we end up with these ones here, the product of these, and this will be x squared minus 1 into a c, into a c over our numerator, which is x plus 1 into x minus 1 into x plus 2. Alright, so you can realize that this denominator is actually the same as the denominator on the left hand side. This is a difference of two squares, so it's like x squared minus 1 into x plus 2. So since this is equal to this denominator on the left, we said we compare now the numerators. So we can conclude that the numerators on the left, which is 7 minus 2x, 7 minus x squared is identical to the numerator on the right hand side, which is a into x minus 1 into x plus 2 plus a b into x plus 1 into x plus 2 plus the c into x squared minus 1. So we find the values of a, b, and c. So I'll begin by, I can let my x to be 1. If I let my x to be 1, I'm sure if I put a 1 here, this will be 0, and it means all of this will disappear. And wherever I have x minus 1, it will disappear. For example, here, this also will disappear. So it means the left hand side will be 7 minus 1 squared, which is 1, equaling 2. When we put a 1 here, this would go, so we have a 0 plus, substitute a 1 here, this will be a b into a 2, 1 plus 1, then into, this is a 3, so 1 plus a 2, plus this will be a 0, because when you put a 1 here, this will be 1 minus 1, which is a 0. 0 times c is 0. So this one gives us the left hand side as 6 equals to the right hand side, we have 6c bar. So on dividing both sides by 6, we end up with our bar as a 1. Okay, let's find the value of the next value. That's maybe of b. If I want b, it means I have to eliminate a and maybe also c. So I can let, if I let the value of x, be equal to -2, let's see what happens. On the left hand side, I'll have 7 minus, this will be a 4, that is -2 squared, which is equal to, if our x is -2, when we put -2 here, -2 plus 2, it is a 0, so we expect this to disappear. We shall end up with a 0 there, plus let's check here, we also have here x plus 2, when we put here -2, it will also be a 0, so it means also b disappears. And we remain with a c into, this is our x is -2, when we put it here, we substitute here, we end up with a -2 squared, which is a 4 minus a 1. So when we subtract here, this gives us a 3, which is equal to a 3c. So when we divide by 3, we end up with c as 1. Now, the remaining values for, we have b, we have c. So let's find a. I can let the value of x be equal to -1. If it is -1, it means the left hand side will give me 7 minus a 1, because this is a -1 squared, which is a 1, equaling to What do I have on the right hand side? This is a into, if this is -1, I end up with a -2 here, into, this will be a 1, -1, plus a 2, then plus. If we have -1 here, this will disappear. Like we have -1 plus 1 is a 0, so the b and all its parts go. What about here? If we put here -1, here we add a 0. When you put here -1, this is -1 squared, which is a 1 minus 1, 0. So this also disappears. So we remain with the 6 equaling to -2a. So it means our a is equal to -3. So we rewrite now our expression by just substituting the values of a, b, and c back here. Just substitute the values of a, b, and c back here, and we have our partial fractions ready. So it means our final answer, we have been able to express this fraction 7 minus x squared over x squared minus 1 into x plus 2 into its partial fractions. Our a was -3 over, the denominator was x plus 1, plus our bar was 1 over, the denominator was x minus 1, then plus our c was 1 over the denominator, which was x plus 2. We can leave it there, or we can just rearrange like this, minus 3 over x plus 1 plus 1 over x plus 2. And these are partial fractions under type 1. We shall look at other types in the next videos. Thank you for watching. Don't forget to subscribe, to like, share, and comment. Goodbye.